Been getting a lot of questions about how to complete the nomenclature part 2, so I did want to make sure and clarify some of this. So for the nomenclature part 2, you have a structure that is in your box that has a line underneath one of the letters, or one of the symbols. That symbol is the symbol for the central atom in the structure. So that's the atom that's going to be in the very center of your Lewis structure. When you draw the Lewis structure, that's going to be in your first box. So if I want to draw the structure for CF4, first I need to figure out my valence electrons. So carbon, if we look, it's in group 4A, so it has 4 valence electrons. Fluorine is in group 7A, so it has 7 valence electrons. And when we look at the formula, carbon has 1 atom. There's 1 atom. Fluorine has 4 atoms from the formula. 4 times 1 gives us 4 electrons from the carbon. 7 times 4 is 28 from the fluorine. Remember, we're only looking at the valence electrons. So our structure is going to have 32 valence electrons in it. Then we arrange our atoms around the central atom. So our central atom is going to go in the center. We have 4 fluorines, so I'm just going to arrange them around evenly. Now, each of these is going to be bound to the carbon, so I'm going to just connect them with a single bond. And then I check the octet. I check the carbon first because it's really easy to forget the center atom. Carbon has 1, 2, 3, 4, 5, 6, 7, 8, because remember these are shared electrons, so they count for both atoms. The fluorines each have 1, 2. I need 8 because remember we have to follow the octet rule. So 1, 2, 3, 4, 5, 6, 7, 8. Our electrons stay paired. So I'm going to put that all around. Once I actually fill the octets of each atom, then I check to make sure that my total of all the electrons in this structure is exactly equal to 32. If I've done that, so if everything's got a full octet and it equals this total here of 32, then I have the correct Lewis structure. Once I have the correct Lewis structure, then I can complete the rest of it. So for bonds, I'm just going to count the number of bonds. It doesn't matter whether this is a single bond, a double bond, or triple bond. I just count each up. I have 1, 2, 3, 4. Lone pairs, I'm only looking at the lone pairs on the central atom. So I always look at this carbon. Carbon has no lone pairs. So it doesn't have any of these. So lone pairs are these electrons that are paired up but not attaching. So they're called lone pairs. Carbon has no lone pairs, so that's 0. So my total electron groups, I just add these 2 up for 4. For the 3D shape, I need to look back at my at the lab. So we look back at this table that's in your lab. So it's on the first page of your lab. The number of electron pairs here, this is that total that we were looking for. The total was 4. So we look here, 4. The electron pair geometries are, we have 0 lone pairs, because remember it was 4 total. We have 0 lone pairs, so we can look here. And the shape is going to be tetrahedral. So here I would write tetrahedral. For polarity, this is where it's important to go ahead and build our molecule. So that's what the simulator is for. I'll show you what you do with the simulator. So the molecular model simulator, so this is right in the lab. So you click on the model. I'm going to remove all so that I can actually start with a blank. This purple, this is going to be our carbon. We have 4 things that are attached to it with single bonds. So I have 1, 2, 3, 4 fluorines. And I don't have any lone pairs, so I'm actually done building my structure. This allows me to see this tetrahedral shape in 3 dimensions. I can even double check, click the molecule geometry to see the tetrahedral. If I spin this around, this can help me to easily see that this structure is symmetrical. Essentially, even if the bonds in this are polar, the whole compound won't be polar because it's completely symmetrical. It's kind of like a completely balanced tug of war, where there's tugs along all these angles, they're all going to cancel each other out. This is very much like if you had a tug of war in 2 different directions. They were pulling completely opposite. If we have a symmetrical molecule, then the molecule is going to be non-polar. So I could write here either for polar, it's either no, I would write non-polar. Either option makes it clear. And that's, how we complete that part of the table. Now I've included H2S here as well. I'll show you what it looks like in the molecular model simulator, but I'll quickly go through the Lewis structure. So Lewis structure, hydrogen is in group 1A, so it has 1 valence electron. There's 2 hydrogens, so there's 2 total valence electrons from hydrogen. Sulfur is in group 6A. There's only 1 sulfur. So 6 valence electrons, 2 plus 6. It gives us a total of 8 electrons that we're going to have in our structure. Sulfur is the center atom. Hydrogens. Now remember, with the octet rule, it's 8 electrons for everything except for hydrogen. Hydrogen only needs 2. So we're going to attach each of these hydrogens to the sulfur. Hydrogen here has 1, 2. So it's already happy. This hydrogen also has 1, 2. It's happy. The sulfur here has 1, 2, 3, 4. I need 4 more. So I need to put lone pairs on this sulfur now. My total structure has 1, 2, 3, 4, 5, 6, 7, 8, which is the total that I got at the beginning. So that tells us that our structure is correct. The number of bonds, sulfur has 1, 2. I'll put a 2 here. The number of lone pairs, there's 1, 2 lone pairs on the sulfur. We only look at the sulfur, remember. 2 plus 2 equals 4. Keep in mind this total is not always going to be 4, so it's going to be important to actually figure out what that is. And then we need to look at the 3D shape. So remember our total was 4. And there was 2 lone pairs. So we look on the 4 for the total, 2 lone pairs, and we get bent or angular. Typically I just use the word bent. Some people prefer angular, but you should be able to identify it based on either name. All right, so our shape here, our 3D shape is bent. To figure out whether it's polar or not, I need to go and build it in the molecular model simulator. So I start with my center atom. Notice I've reset everything again in here. I have on this sulfur, I have 2 singly bonded hydrogens. So I'm just going to click on here to get my 2 hydrogens with 1 bond. So the single, double, triple bonds here. So it's single bond. But the sulfur also has 2 lone pairs on it. So I need to make sure and select 2 lone pairs. If you don't do that, you won't get the correct shape. Notice that this agrees. My molecule geometry is bent. Toggle that on and off whether it helps you. And you can see what the shape looks like. Sometimes it can help to see it with the lone pairs, but this one I think it helps a little bit more to toggle the lone pairs off so you can see very clearly that this molecule is not symmetrical. This bent shape means that there's hydrogens on this side, but if you come from this side of the molecule, there's no hydrogens. This molecule then is polar because there is a difference across this molecule. That difference is caused by those lone pairs. And you'll notice that as you build these molecules is that over and over again, you're going to see that the molecules that have a lone pair or more than one lone pair on this central atom are more likely to be polar than to be nonpolar. So this is something that you want to go through and practice through and see the patterns as you create these structures. So I put down either yes or polar here for H2S. So notice these are two structures that are not in your lab. So I want you to try and apply what you've seen here to the lab. Do make sure and also look at the other videos on how to do different types of Lewis structures because you will need to really practice that.